Okay, today's lesson is 3.4, and we're going to talk about how do we simplify radical expressions. And this is on page 150, where I'm starting. Now, there are three things that you need to know about the simplest form of a radical expression. So whenever a question says to simplify and it has a radical in it, these are the three things that you need to make sure that it does not have. First of all, there have to be no perfect squares, such as the square root of 4. That can be simplified. Also, you could also say the square root of 8, because 8 has a factor of 4 in it, and we'll go into how to do that in a moment. The other thing is you don't want to have x squared. Even the square root of x cubed has a perfect square in it because it's x squared times x, and we'll go into how to do that in the lesson. The second thing you need to have is that there are no fractions under the radical. For example, if you had the square root of 1/2, you don't want that. Or if you had the square root of 1 over x, even that, because this x and the 1 are under the radical. There are other examples, and we'll get into how to do those as well. And then the third is that there are no radicals in the denominator. So you wouldn't want to have something like 2 over the square root of x, or you would not want to have 2 over the square root of 7. Anything like this where you have a radical in the denominator as well. So those are the three things that you want to look for whenever it says the simplest form, when it says to simplify. Okay? So these are the three things. You need to have those memorized so that when it says simplify, you know what it means to simplify. Now, rationalizing the denominator. Okay? When you rationalize the denominator, okay, for this one, rationalizing the denominator, and this is the process in which we get rid of the radical, like when we had 1 over the square root of 7. This would eliminates the radical from the denominator. And the reason why we call it rationalizing is because the square root of 7 is an irrational number. And we do not want to divide by an infinite number that goes on and on forever. So we would rationalize it. And then 7 is in the denominator. So that is why we do it, because you just don't want to divide by a number that goes on forever and ever. It is irrational. Now, radical conjugates. Let's talk about those. For the radical conjugates, this is where you have two terms. If you have like a plus the square root of b, and then a minus the square root of b. And the a and the b represent numbers. So an example of a radical conjugate would be, say you had x plus the square root of 3, and then x minus the square root of 3. Or you could have, more often you have something like 3 plus the square root of 2, and then 3 minus the square root of 2. So this is where you're expressing, you could put this in a decimal form, but this is 3 plus a irrational number, the square root of 2. And we usually keep these this way because this radical 2, it's an irrational number. So we usually, when you get into higher math, you'll keep it this way because you'll get the most accurate answer if when you go to finally, whatever your application is, you keep it this way so you don't have more rounding errors, is what it results in, is additional rounding errors. So we would keep it this way. And as you learn more and more math, you'll see where that comes in, as well as science, because these things do come up in science as well. Okay, next we have the product property. Okay. Now, the product property is what we're going to use today in order to rationalize, in order to simplify all of these different problems. And what that says is that if I have the square root of a number times another number, that's equal the square root of my first number times the square root of the second number. So we'll need to be finding, and then A has to be bigger or equal to 0, and B also has to be bigger than, basically, you can't take the square root of a negative number. So these two numbers we're going to assume are always positive. And an example of this would be if we had the square root of 9x, it would be the square root of 9 times the square root of x. And since we can break this apart, we already know the square root of 9 there is 3. And then we cannot take the square root of x, so that's times the square root of x. And it is written as 3 and then a radical next to it and an x. And 3 square roots of x is usually how you would hear it spoken, is 3 radical x, or 3 square roots of x. Because there it literally means it's the square root of x plus the square root of x plus the square root of x, which is 3 radical x's. See, this is, I'll write it here. It's the square root of x plus the square root of x plus the square root of x. And this would be 1, 2, 3 of them. Just if you have, okay.